All right, we are going to be completing the Unit 7 review, and just so you are aware of what reference sheet you will have on the test for other formulas, this is what it looks like. So if you notice, we have area of a parallelogram, area of a triangle, rectangle, circle, square, circumference formula, area of a rhombus, area of a kite, area of a trapezoid, regular polygon, so hexagon, pentagon, octagon, all of those. And then you have all your volume of a prism or cylinder, volume of a pyramid or cone, and volume of a sphere. And just real quick, with area of a prism, volume of a prism or cylinder, remember that you do have special volume formulas if you have a rectangular prism, and these are just kind of optional. But it's volume equals length times width times height. And then for your cube, you have volume equals side cubed. But again, those are optional. Those are just, if you want to have them, you'll just have to remember them. So, getting into the actual review, we are going to start with the free response ones. Remember, you are supposed to be bubbling in the sheet that you have at the very back. And at the end of this, I'll show you that sheet that I already have bubbled. So, first, starting with classifying a solid, this shape is a cone because it has a circular base and it meets the top. Remember, when you're classifying, pyramids and prisms are named off of their bases. So that's just a side note to know for these, named by base. And I promise I'm going to write better than that. Looking at this cone, we have one vertice, which is this tippy top one. So this is vertice Y. And then our edges, there is some debate on whether or not there is an edge on a cone, because this edge is technically circular, but this is still considered an edge. So there is one edge, and there's not really a good way to name it. So I would just draw a little arrow to that little piece where the bottom of the circle meets the extra rest of it. And then our actual base would just be circle Z. And you're just naming the shape and what letters represent that shape. For B, we have a pyramid, and we know it's a pyramid because it only has this one base at the bottom. So this is, you can either say a square pyramid or a rectangular pyramid. I can see it both ways. I'm going to put rectangular just because it's a little bit safer of a bet. And so to find the vertices, remember your vertices are where three or more faces come together. So in this case, it would be A, B, C, D, and E. So you just list them A, B, C, D, and E. And the main thing with this is that you're able to identify what the vertices are so that you can count them. Because if I ask you how many vertices are on a pyramid, then you should be able to just say, oh, there's 5 for this one. You may not have to actually name them, but still be able to recognize them. For the edges for this, it's where 2 or more faces come together. So I would start with the E and have EA, EB, EC, and ED, because now I have all 4 of these pieces taken care of. So then I just need to take care of the bottom 4. So that would be AB, BC, CD, and DA. And again, just like the vertices, it's more so about, can you count how many are there? Because you won't have to actually name all of them. It's just going to be, can you recognize how many there are based on what you're given? So then our base, we just say the shape. So this is a rectangle and the letters that represent it. So A, B, C, D. All right. So for your multiple choice, you do have to make sure you bubble the sheet at the very end. But for the sake of not having to scroll a bunch, I'm just going to show you it at the end and just kind of give you some tips on filling out that bubble sheet if you're kind of confused on it. So number 1, naming the solid. We look at this shape that we have off to the right, this beautiful little pyramid. And because it has 1, 2, 3, 4, 5, 6 sides at our base, I know it's going to have a hexagonal base, and it's a pyramid, so it is a hexagonal pyramid. And actually, I think I'm just going to highlight the answers. That might make life easier. Okay, so again, pyramids and prisms are named based off of their shape of their bases. So just keep that in mind as you're doing this. Let me just change the size so we don't have to go back over. Okay, so how many vertices does the solid have? If we look vertices, and I'm going to get rid of my extra marking so it's not confusing. Boop. Vertices would be G, F, A, B, C, D, and E. So that gives us 1, 2, 3, 4, 5, 6, 7 of them. So because of that, that would be a none of the above. Okay, so then for the next one, number 3, we want to know how many edges does this thing have. So again, I'll get rid of this extra stuff. Looking at the edges, and we'll make this blue, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we actually have 12 of these edges. So that gives us another none of the above. And none of the above is totally fine. They did that on purpose. And then how many bases does the solid have? We just have one main base because that's how we named it. And again, that base is that hexagon. So then what type of solid is a shoebox? Well, if you think about it, a shoebox looks something, like that, which that is not perfect, obviously, but that would be a rectangular prism. Remember, prisms have 2 bases, and even though it may or may not be sitting on the base, it still needs to have those 2. So then a can of soup. Most of you have probably seen cans of soup, I would hope, but it would look like this. And then that would be a cylinder because it is a prism that has 2 circular bases. So from this net, when you have a net, just pretend you're folding it up. If you could actually fold it up. So looking at this, this would fold up to be over here. This would fold up to be over here. This would be this side, this one would be this side, and then this would be the very top. So if you notice, all of this would just wrap around that hexagon. And because I have 2 hexagons, I know it's a prism. So then it would be a hexagonal prism. So D. For number 8, what shape is the cross-section formed by the intersection of a cone and a plane parallel to the base of the cone? So with this one, it might help if you draw yourself a picture. Oh goodness, I don't know why I can't draw today. Okay, so good enough cone. So because the plane is parallel to the base, I know that that plane would cut through right. Well, it's hard to show because this isn't actually 3-dimensional, but you'd be cutting it parallel to the base if the base was just this flat. So because I'm cutting it parallel to the base, if you notice, if I draw that black line through the base, I have it kind of curves down and curves up. And so because of this cone, I know that this would come down and be like that. So your cross section is actually what's happening in here. If we looked at that part of the cone from the top looking down, that shape would be a circle. And just keep in mind that your cross sections should always be 2-dimensional shapes. And that'll be a quick way just to get rid of some of your extra answers in case it's seeming strange. For number 9, classifying this figure, because we have all of these bases, really, oops, didn't have the right thing selected. Oh no, it's doing extra stuff. So, while it loads, there it goes. Because I have bases that are rectangles and it has more than one base, it is going to be a rectangular prism. And rectangular prisms is one of the ones that it doesn't really matter which side it is, it's still going to be a rectangular prism. So it could stand up tall if it wanted to, and it'd still be a rectangular prism. It can kind of be seen from any point of view. For number 10, how many and what shape are the bases of a pentagonal prism? The key thing here is that it's a prism, so I automatically know I have two bases. And then because it's a pentagonal prism, I know that my base is a pentagon, so then that leaves me with answer D, 2 pentagons. Okay. Looking at this net, I know that if I were to roll this up, this rectangle would actually just become like a piece, like a circle. And if you don't believe me, go ahead and roll up your paper and you'll see it makes a circle. And so because I have two circles, then I know that with these, it is going to be a cylinder because I have two circular bases. Okay. So now getting into volume, because this is a rectangular prism, you can either use the volume equals base area times height because that is the very general volume formula, or if you still remember back in the good old days when it was just volume equals length times width times height, then you can also just do 16 times 4 times 6. If you do base area, depending on what you define as your base, I would say what it's sitting on is its base, so that would be V equals 16 times 4 times your height of 6. And 16 times 4 times 6, oops, I typed it wrong the first time, would be 384 centimeters cubed, which gives us answer E. This is still not quite bad enough. There we go. All right, so then for number 13, we have a volume of a right cylinder, and the formula for that is either volume equals base area times height, or instead of base area, you can use pi r squared because every cylinder is going to have a base of a circle. So then you'd have pi r squared h. Does not matter which formula you use. Personally, I prefer the one on the right. So then, because my radius is 4, I would have V equals pi r, not r, pi times 4 squared times 12. And so then 4 squared is 16 times 12 is 192 pi. And so because they're asking us to round to the nearest hundredth, that's where you need to be careful because it is 192 pi, which is B, but because we want nearest hundredth, we'll just multiply by pi. And that gives us a volume of 603.185. And so just in case you are still kind of iffy on rounding, nearest hundredth, that means I need to round to the 2 decimal places. With that 8, I look to the number next to it. That is a 5, which tells me that that 8 needs to be rounded up. So it's going to be 603.19, like that. Oops. So then that would give us answer D for 13. Okay. For this oblique prism, remember your volume formula does not change even though it might be slanty. So this would be volume equals base area times height. My base area would be 7 and 2. So we'd have 7 times 2. And then our height is 3. So 7 times 2 is 14, times 3 is 42. And this is one that I do want to show you the answer sheet real quick because this does not have a multiple choice. It does actually have a fill in the bubbles. So just to show it to you real quick, oops, there it is. Notice my 42, I just write the number up at the top and then you just bubble in the bubbles that correspond to it. If you want, you can also write it on the left side so that you have 42 over here. Obviously that first one would go away, but you just have to make sure you bubble according to what you have. So we'll do the same thing for 15, which I know you see the answer now, but it'll be okay. So going back up to 15, where is it? There it is. So because we are finding the volume of a cube, if you want, you can draw a picture. I don't know if it'll help much, but if you're really visual, it will. So we have 0.75 for all 3 of our dimensions. So then to find my volume to the nearest tenth, I would have my base area times my height. And so my base area would be 0.75 times 0.75. And then my height would also be 0.75. Now you could also just put this as 0.75 cubed. But then when you do that, you get that your volume is 0.421. And again, we wanted nearest tenth. That is going to matter on the test. So remember, tenth is the first decimal place. Look to the next of it, or next to it. Since that's a 2, we're going to keep that 0.4. So my final volume is going to be 0.4 meters cubed for this shape. And it does not matter if you put 0.4 or 0.4, it'll still be fine. So with that, because I know some people have been asking about why is the number smaller, just remember, because you're multiplying 3/4 times itself, you're slowly taking away 1/4 of it every single time. It's kind of like when you multiply 1/2 times 1/2, it's actually 1/4, so it's smaller. But it's just because you're multiplying by a number less than 1 that your number will keep getting smaller. For number 16, we need to find the volume of the regular octagonal prism. I did it again, dang it. There we go. There it is. Okay, so for this octagonal prism, I'm going to get away from pink. I'm sick of pink now. So you are going to need to find the apothem in order to be able to do this. So if you notice, remember that you'd have to take a little slice out of this. So if you look at the big slice, in order to get the big angle, you would do 360 divided by your number of sides. So in this case, it is 8. So that would give us 45 degrees. But then, remember, you're really only looking at half of it, because you're drawing in the apothem, which is where the purple line is. So then, because I'm only looking at half of it, I'm going to divide this by 2, which would give me 22.5. So I know this angle in here is 22.5 degrees. So then, to find my opposite side, I have to go back to the fact that my full side was 10. So if I know that this entire thing is 10 millimeters, that tells me that this side is 5 millimeters, and this side is also 5 millimeters. So then we're really focusing on just this one triangle and all this information that it entails. So looking at that one triangle, I would have to use tangent because I have opposite and adjacent. So tangent of 22.5 equals opposite over adjacent. So then to solve this, we will multiply by the apothem, or the A. So we have A tangent 22.5 equals 5. And by the way, if all these letters are confusing to you, feel free to put a big multiplication sign in there so you don't forget it's multiplication. But then we divide by tangent 22.5. And then 5 divided by tangent of 22.5 is 12.071. And personally, I'll probably just keep that to 3 digits for now. So then, because I have that, I can go and find what my actual base area is. So my base area is my apothem times the perimeter divided by 2. This is just area of a polygon. So then we plug in what we know. The apothem is 12.071. And then our perimeter would be the 10 millimeters times 8, because there are 8 sides, so that would be 80. And then we divide by 2. So 12.071 times 80 divided by 2. And I get that my base area is 482.84. And we're rounding to the nearest tenth, so I'm going to go 84, and this is where it's annoying, it's 8427, so I'm going to say it's 482.843. Honestly, what I would do with this is just, if you're using your calculator, just keep the numbers running. Don't round at all. You can write rounded versions on your paper if you want, but you'll get a much more accurate answer if you're just using the calculator to do all the hard work for you. So then, because I have my base area, now, and this is all sorts of funny. So this was step 1, this was second. So then third, we're going to actually plug it into the volume formula. So we have base area times height. In this case, my base area was the 482.843, and we're multiplying it by the height of 15. So then again, I'm running my numbers right now. So even though I have a rounded number written down, I literally on my calculator just hit times 15 and taking my previous answer and multiplying it by 15 to get that volume equals 7,242.6. And actually, let me see real quick, because I was doing this with someone, and I think without rounding, or when you do round, it does make a difference. So let me see, 843 times 15 div. So I do get 7,242.6. So earlier today I was getting just 7,242. With this one, and we double check the test so that this doesn't happen. Technically, we got 7,242, which would be E, because it's none of the above. But if you put C, I can see that working as well. So I would accept E or C in this case, and that's just something that we'll have to fix for next year to make it work a little bit nicer. So then, going through, now it's bugging me that I don't know why. So, wait, I think I might know what it is. So if you round your apothem to 12.07, when you round that to 12.07, it makes your base area 482.8. And then when you plug that base area in times 15, you get 7,242 even. So again, I'll accept either. We just need to change that for next year. So to find the volume of the cylinder, we're going to give our answer in terms of pi and round to the nearest hundredth. So looking at this, again with cylinders, you can still use that volume equals base area times height. Me personally, I would rather just use volume equals pi r squared h, because it's much easier just to plug it in. So my radius, since my diameter is 8, my radius would be 4, because you're just dividing it by 2. So we'd have pi 4 squared times 2. And so 4 squared is 16, and 16 times 2 is 32. So that would give us 32 pi. And if you notice with this, none of the answers are 32 pi. And there's really, you can double check it if you want. 4 times 4 is 16. 16 times 2 is 32. But since none of these have 32 pi, I can just say, I know it's none of the above. So then, we're going to find the volume of a cylinder with base circumference of 18 pi feet and a height of 10 feet. And then we're going to give our answers in terms of pi and round to the nearest hundredth. So because my base circumference is 18 pi, I'm going to set the formula for circumference, 2 pi r, equal to 18 pi. So then, by solving this, I'm going to get my radius. So I'm going to divide by 2 pi. And the 2's cancel, the pi's cancel, so we're just left with radius on the left, where the pi's will cancel, and then you have 18 divided by 2, which is 9. So then if I want my volume, again, I prefer the pi r squared h. You can use the base area times height if you want. But that would be pi 9 squared, and then our height they told us was 10. So then 9 squared is 81, times 10 is 810. And then we have 810 pi. And if you notice, that will give us C, because that is the only 810 pi that we have. Yay! All right, for number 19, your number that I have highlighted, this 8, is probably cut off by the hole punch if you have a hole punched one. So just keep in mind that is an 8 in case you need it. But because this is a regular pyramid, the formula for volume will be volume equals base area times height divided by 3. So my base area, we have 7 and 6. So that would be base area is 7 times 6, which is 42. So then I know that I have 42 times my height. Remember, your height has to go straight from the top of your shape down to the bottom and make a right angle. If you don't see the little right angle symbol, it's not the height. But in this case, we know that the height is 8, and we are dividing by 3. So 42 times 8 divided by 3 is 112. And by the way, if you're just passively watching this video and just kind of getting the information, that's fine. But just keep in mind that you need to make sure that you are able to do these calculations with a calculator so that you can make sure you actually can do it on your own. But then that's 112 inches cubed, which would give me answer A. For number 20, volume of a cone is going to be very similar to what we just had, except if you want, you can write as base area times height. Again, I prefer just writing pi r squared h divided by 3. So in this case, my radius is 5, so I'd have pi 5 squared times a height of 21, and I'd divide it by 3. 5 squared times 21 divided by 3 gives me 175 pi. And 175 times pi would give me 549.778. So again, with rounding, that is my hundredths, and the 8 tells me to go up, so this is going to be 549.78. So then, boop, 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 boop. That would give us 175, 54978, answer B. Okay. For 21, you need to be careful because 100 is the slant height. So remember, we are trying to find the actual height, and it has to have that right angle. So since I have two sides, and since I know this would make a right triangle, I can use Pythagorean Theorem. And I'm going to use H instead of B, just so that I have a letter that I know I'm going to be plugging in. So then 28 squared is 784. And 100 squared is 10,000. When we subtract 784, we get that h squared is 9,216. And then you take the square root, and you get that your height is 96. So then, boop, to find the volume, we have volume equals your base area times your height divided by 3. But again, my base area, I prefer pi r squared h divided by 3, because then I can just plug everything in at once. So that would be pi, my radius is 28 squared, my height is 96, and we are dividing by 3. So 28 squared times 96 gives me over 75,000. And when you divide by 3, it gives you 25,088. And that is pi. So then multiplying by pi, that gives us 78,816 point, and this is nearest hundredth, 276. So because that's a 6 next to the 7, it's going to be 78,816.28. So this one and this one. So then looking at our answer choices, that would be option B for number 21. For 22, finding the volume of the sphere, we're going to have volume equals 4 times pi times r cubed divided by 3. So because 16 is my diameter, I know my radius is 8. So volume equals 4 pi 8 cubed divided by 3. 8 cubed times 4 divided by 3 is 682.6 repeating pi. And I'm only writing that because, again, on my calculator, I'm just hitting times pi and not even rounding in it. So I get that my volume is 2,144.66, which gives me answer D. And on the test, there are questions where you'll have to be doing this. If there is some rounding, you're just going to be picking the answer that's closest to yours. So for number 23, looking at this sphere, we're going to be using the exact same formula. Volume equals 4 pi r cubed divided by 3. So then that would be 4 pi 9 cubed divided by 3. So 9 cubed times 4 divided by 3 gives us 972. And this is pi. So then when we multiply by pi, because we want the nearest hundredth, that would be volume equals 3,053.628. So then, again, we're looking at the 2. The number next to it tells us to go up. So it's going to be 3,053.63, which is going to be answer B. For number 24, almost done, we want to know what is the radius of a sphere whose volume is 36 pi. So again, volume is 4 times pi times r cubed divided by 3. So we are actually looking for, this is unusual, the radius, and we are given the volume. So we can still fill in and solve an equation with the information we have. So, oops, didn't mean to get rid of that. So instead of plugging in for r, we're going to replace that v with 36 pi. So then, to get rid of this 3 on the bottom, I would multiply by 3. And by doing that, these 3's will cancel, so that we have 36 times 3, which is 108 pi. And then, because we are solving for r, we are going to divide by 4 pi, so that my pi's cancel. And 108 divided by 4 is 27. So then you're going to have to do the cubed root of this, because it's r cubed. And on a calculator, generally they don't have a cubed root button. So in order to do that, you're going to actually hit your exponent button, which kind of is under the clear if you're on using a graphing calculator, but it looks like this in the box. But you hit that, and then you're going to put 1/3, 1 divided by 3, in parentheses after that little symbol. And that'll tell you that r equals 3. And if you think about it, 3 times 3 times 3, this would be 9 times 3, and 9 times 3 is 27. So that 27, the cube root of 27 is 3. So then that would be A. And then last but not least, we have this beautiful composite figure. So we're going to find the volume of both shapes, and then we're just going to add them together. So starting with the cone, that would be volume equals pi r squared h divided by 3, or your base area times height divided by 3. So my radius, even though it's not directly labeled, this cone is just as wide as the square, so my radius is going to be 3. So we have pi times 3 squared times height, which is 4, divided by 3. 3 squared is 9, times 4 is 36, divided by 3 would give me 12 pi. And because this is going to be added with something that's going to be a whole number, we're just going to go ahead and estimate what that would be. So we multiply by pi, and we get 37.699. And it's 6991, so I'm just going to leave it at 699. But then we're going to come back to that in a second. We're going to find the volume of the pyramid. So looking at the pyramid, it's going to be the same formula, almost. Volume equals base area times height divided by 3 instead of pi r squared. But our base area is going to be 3 times 3. So that would be 9, which I'll write it as 3 times 3 for those of you that need to see everything. And the height would be 4 again. So then that would be 9 times 4, which is 36, divided by 3. So I get that my volume is 12. So then, because I now have my two volumes, I'm just going to add them together. So that would be 12 plus 37 point, and since it's nearest tenth, I'm going to go ahead and round this. Tenth is this first digit. The 9 tells me to go up, so this is going to be 37.7. And 12 plus 37.7 would give us 49.7. So that is answer C. And on the key, we might have E on accident, and I'm trying to see if maybe I made a mistake real quick. But the cone, oh, I did, oopsie. Let's see if you can find my mistake. I'll tell you it's in cone. So didn't even realize that, oopsie. So the diameter is 3 in this circle because it goes all the way across. So really my radius is 1.5. So then 1.5 squared times 4 divided by 3, oops, is 3 actually. So this would be 3 pi, and then 3 times pi gives me, not that, 9.42, which would just be like 9.4. So then really this 37.7 is actually 9.4, and then 12 plus 9.4 is 21.4, which is none of the above. Okay, I'm glad I caught that. So make sure you're being careful, because obviously, as you can see, it's really easy to mess up the radius sometimes because the radius is half. So just make sure you're checking for silly mistakes, kind of like I just did. And really the only reason I knew something was wrong was because I knew the answer wasn't supposed to be C. So just take that extra second, double check your work. It won't kill you, I promise. So just a quick recap with your answer sheet. You do need to bubble it in so that I can just scan it real quick and it's nice and easy. It's also good to bubble it in because this is basically what your answer sheet for your test looks like. So if you have any questions on filling in the answer sheet or any of that, that's just ask me, no problem. You do not have to fill out this part or this part for me. So don't worry about those. You can if you really want to. Well, besides the teacher use only one, but you don't have to. So if you have any questions, feel free to ask me. And if you've been following along and you just want to see what the answer sheet should look like real quick so you don't have to flip a bunch, and that should be all of it, there you go. So let me know if there's any questions.